Okay guys, here we're going to look at some indirect titration examples. So indirect titration, a bit similar to back titration, involves two equations. So what we're using here is we're using the product of the first one in the first equation, in this case the iodine. So whatever's produced there, we're then reacting that further with a standard solution of another product to form that's the second part of the actual titration. Okay, so we'll have a look at this question here. So we've got a concentration of sodium hypochlorite as a commercial bleach solution, and was determined as follows. So a 5 ml sample of bleach solution was diluted to 25 ml. An excess of aqueous iodide ions were then added to the diluted bleach solution to react with all the hypochlorite ions according to the following equation. So there it is there. The second equation, the resulting triiodide ion is then titrated against a known solution of 0.0993 moles per litre sodium thiosulfate solution. The titration equation is there. Okay, so that's our equation 2, and the titer recorded is 38.5 mils. So that's of the sodium thiosulfate to react with all of the triiodide ions. Okay, so the first question is calculate the number of moles of thiosulfate in the titer. Okay, so just let me get to the sketchpad. So that's a little bit unclear, can't do much about that. So part A, number of moles, asking for of the S2O3 2 minus. Minus equals, so a molar concentration is 0.0993 moles per litre, times that by what we got from our titer down here, so that's 0.0385 litres, and we get an answer there of 3.82 times 10 to the minus 3 moles. Okay, so it took 3.82 times 10 to the minus 3 moles of this thiosulfate to react with all of this iodine. Okay, let's get rid of that. Okay, so hence calculate the number of moles of the triiodide produced in the reaction. Okay, so in this particular reaction we've got a molar ratio of the triiodide is 1 mole, and the thiosulfate we've got 2 moles. So we just need to work out the molar ratio of that. So how, if I remember from our lessons, how I tend to work that one out is our number of moles of our unknown divided by the number of moles of our known. Okay. Moles of our known. Okay, so in this case it's the number of moles of the iodine ion, I3, that is the one we're trying to work out, I3 minus, divided by the number of moles of our thiosulfate ion. 2. Okay, and so that equal to, so I3 is, if you look on here, it's 1 mole of that, divided by the 2 moles we have of the thiosulfate. Okay, and then we just rearrange that to find out, so N of I3 minus equals a half times number of moles of our S2O32 minus, okay, which equals a half times, so that's the number of moles from part A, which is 3.82 times 10 to the minus 3, and that gives us 1.91 times 10 to the minus 3 moles. Okay, so the triiodide, we ended up with 1.91 times 10 to the minus 3 moles of that. Okay, so that's our answer. Put that in here, 1.91 times 10 to the minus 3 moles. Okay, part C, hence calculate the number of moles of ClO in the 5 ml sample of bleach. Okay, so we know that I3, if we look at the first equation, it's 1 mole of the I3 reacts with, and the ClO is also 1 mole, if we look at that. Okay, so we've got from that second first equation, so we've got from the second equation how many moles of I3 we've got. So we go back to the first equation, we've got 1.91 times 10 to the minus 3 moles of I3. Therefore, it's a 1-to-1 ratio, so the ClO is going to be the same. It's going to be 1.91 times 10 to the minus 3 moles. Okay, I'll just put in brackets number of moles of I3 is the same as the number of moles of ClO equals 1-to-1. Okay, part D. Hence calculate the molar concentration in moles per litre of ClO in the 5 ml sample of bleach. Okay, so here we use our molar concentration, so concentration here. So it's the number of moles over volume. So we know we've got number of moles is 1.991 times 10 to the minus 3. Okay, divided that by our 5 mils, which is 0.00500 litres, okay, which are those significant figures you follow through, equals 0.38282, and that's moles per litre. Okay, so moles per litre, we've got here, moles per litre. Done. Okay, and finally part E, calculate the mass concentration in grams per litre of the sodium thiosulf of the bleach. So that's the sodium hypochlorite, I should say, in the 5 ml sample of bleach. Okay, so we've got a concentration here. We've worked out we've got 0.382 moles per litre. And if you times that by the molecular weight of the molecular mass, big M, of the NaClO. Okay, I'll just put that over here. So the big M of ClO equals, if you look it up in your periodic table, that adds up to we have 74.4 grams per mole, 74.44 grams per mole. Okay, if we go back, I'll just get rid of that so we can write a bit. Okay, so we times that by our molar concentration, 74.44 grams per mole. Okay, get rid of the moles and we're left with grams per litre. So equals 28.4 grams per litre. Okay, there you have it. That's an example of indirect titrations.